This is a hardware overview of our 2-channel solid-state relay controller. This relay controller is a ProXR Lite Series, which includes 2 onboard solid-state relays with 2 connection posts per relay. This controller is available with AC or DC solid-state relays. The AC solid-state relays can be used for AC switching, whereas the DC solid-state relays can only be used for DC switching. It's not possible to mix AC and DC applications with these relays. Also, it's important to understand that solid-state relays have a minimum load requirement. That basically means that you're not able to switch very low power loads through this relay. The relay won't see the load and won't be able to turn it on or off. Also, keep in mind that solid-state relays do not generate a contact closure on these terminals that a voltmeter can see. So if you were to measure the resistance between these contacts and turn the relays on and off, it would not be possible to make an accurate measurement with your meter. Solid-state relays have a minimum load requirement, and it's really important to understand that minimum load requirement has to be met before the solid-state relays can actually activate. This particular controller also includes 2 LED status lights that indicate the on-off status of these relays. Here we have 8 channels of analog to digital conversion. ADC converters can be used to manually control these relays if you map them for that feature, or you can use the ADC converters to read sensors. Anything in the 0 to 5 volt voltage range can be read with an 8-bit or 10-bit resolution. The ADC inputs have to be connected to something at all times. That's kind of a rule of ADC inputs. So what we did is we included 10K pull-up resistors on this board. Now you can change them from pull-ups to pull-downs using this jumper. Basically what that means is all of these inputs will be tied to a 10K resistor and then to 5 volts when it's connected to the pull-up to the up position. When you move the jumper to the down position, it will connect these resistors to the ground. That will keep all of these inputs quiet while still allowing you to use them by feeding a voltage into these ADC inputs. We also include an integrated temperature sensor on this controller. This temperature sensor is connected to this temperature sensor output here. You can run a wire from this temperature sensor output to any of your available ADC inputs and monitor the temperature of this board or your ambient air in the area. Also included is an auxiliary 5-volt power connection. This 5-volt power connection is used for powering external sensors or other electronics should you need it in relation to the ADC converter inputs. You can power this controller through these 2 terminals if you prefer to do a direct wired connection. In our video, we're showing the 2.1mm barrel connector, but you can either use these 2 terminals or the barrel connector. It's your choice, just depending on what you need. Also on board is a program run jumper. The program run jumper is used to set the mode of the processor. Normally the processor should be in run mode for daily use. However, if you need to make some special setting changes to the processor, or if you lose communication with the processor, you can always recover your settings by switching this jumper into program mode and then running our base station software. That will make sure you never lose communication with the controller. Here we have a busy ready LED. The busy ready LED is used to indicate the status of the processor. Normally the processor is ready, but when it receives a command, it will switch over to busy and then back to ready. This is a very fast operation because it doesn't take very long for the processor to handle your commands, and you can send many commands per second to control the relays on this board. Here we've got a USB module installed. The USB module gives you virtual COM port access to this controller. That basically means that when you plug this into your computer, it will mount as a virtual COM port, allowing you to send basic serial commands to control this relay board. You can remove this USB module and replace it with other communication technologies such as Ethernet, wireless, Wi-Fi, Bluetooth, RS-232, and a few other select modules that we have available. If you happen to be using the Wi-Fi module and you need to set the controller or the module into ad hoc mode, you can install a jumper in the ad hoc jumpers here, and that will put your Wi-Fi module into ad hoc mode. That about covers it for this relay controller, but if you have any questions, please let us know. We would be glad to help you out. Thank you.